Hi and welcome! This is a follow-up video on this motherboard, the DFI P5BTX/L Revision C. In the previous video, I repaired the voltage regulation circuit, which involved replacing the power transistor and an SMD resistor. Now that the board is working, let's try to use the fastest Circuit 7 CPU that we can. The CPU configuration is done through dip switches. There are some configuration tables on the silk screen for the voltage, the FSB and the multiplier. But the voltage table shows a minimum voltage of 2.8 volts, a maximum FSB of 66 MHz and a maximum multiplier of 3x. 2.8 volts is way too much for the AMD K6-2 CPUs, which typically need around 2.2 volts. Also, using a multiplier of 3x and an FSB of 66 MHz will only get us to 200 MHz, which is quite slow for a K6-2. But it is typical for such late Socket 7 boards to have undocumented voltage, FSB and multiplier settings, so let's find out what they are. Let's start with the voltage. I am checking the voltage of one of the VCC 2 pins on row B and column 2. Now I'm going to enumerate all switch combinations missing from the voltage table. So I will set dip 4 to off and I will try the 8 combinations of dip 1, 2 and 3. Here is the complete table. As you can see, the voltage goes all the way down to 1.95 volts with a step of 0.1 volts. Now let's look into the FSB. For this we will need to use the oscilloscope and check the clock signal on row AK and column 18. I will try out the missing switch combinations of the FSB table. Off, on results in a 60 MHz clock. With on, off, on we get 66 MHz. With off, on, off we get 75 MHz. And with on, off, off we get 83 MHz. Finally, there are several combinations that give us bad clock signals like these. Here is the complete table. So the highest FSB is 83 MHz. The multiplier is set by the processor, so let's insert a CPU. I'm going to use this K6-2 400. I have set the FSB to 66 MHz and the voltage to 2.2 volts. So let's try out all combinations of the SW1 dip switches 4, 5 and 6. Off, off, on gives us a CPU frequency of 366, so the multiplier is 5.5x. On, off, on gives us a 4x multiplier. Off, on gives us a 5x multiplier. And finally, on gives us a 4.5x multiplier. K6-2 CPUs treat the 2x multiplier as 6x, so with a 2x multiplier we're getting 400 MHz. Here's the complete multiplier table. Now that we know that a K6-2 works fine, how about a K6-2 Plus? Let's try out this one, which is clocked at 550 MHz. We can get up to 500 MHz using a 6x multiplier using the 2x option and an 83 MHz FSB. The good news is that the system boots, but the CPU is identified as a 16 MHz CPU. Let's check out SpeedSys. The CPU is indeed running at 500 MHz with an 83 MHz FSB and a multiplier of 6x. And as you can see, the cache also works correctly. There's a drop at 32K due to the L1 data cache, another drop at 128K due to the on-chip L2 cache, and one more drop at 512K due to the cache on the motherboard. Let's try Doom and Quake. Well, it works, but wouldn't it be nice to get the BIOS to identify the CPU correctly? There's a tool for that, the BIOS Patcher. If you're not familiar with this tool, please check out a couple of awesome videos on it, one by Necroware and another one by bits and bolts. So let's remove the BIOS chip from the motherboard. And let's read it using the Mini Pro chip programmer. Now let's run the BIOS patcher in DOSBox. After writing the patched BIOS on the chip and placing it back on the board, it is time to boot the system. And we're getting some constant beeps and the system does not seem to be able to boot. After some search online, I think I figured out what the problem was. The BIOS patcher relies on an external tool called CB-ROM to pack and unpack the BIOS, and it seems that the BIOS patcher works best with version 2.07, and I was not using that version. So after replacing CB-ROM with the correct version, let's run the BIOS patcher once more. And yeah, the CPU is now being detected correctly. Let me also modify the message string displayed at the top using the modbin tool to clearly show that this is a patched BIOS. For a great tutorial of the modbin tool, please refer to an awesome video by Atheatos. Now that we patched the BIOS, let's run some benchmarks to check if there is any difference. The cache throughputs have improved a lot. I wonder why that is. The performance in Quake seems to be much better. We're getting more than 27 FPS, but previously we're getting around 23. But I have this feeling that this Cirrus Logic graphics card is holding the system back. Let me replace it with this S3 Verge. Whoa, Doom is twice as fast. And Quake is almost 20% faster at 82 frames per second. These performance numbers are very similar to what you would get from a Super Socket 7 system. These are the benchmark results for a 550 MHz Super Socket 7 system as shown in Phil's video. For more details, please refer to the video, the link is in the description. I overlaid my benchmark results over Phil's graph for an easier comparison. Phil's system is using a faster 550 MHz core, but it's also using a Voodoo 3 3500 AGP card. So let me run the benchmarks once again using a Voodoo 3 2000 PCI to see if there is any difference. And yeah, the Voodoo card is slightly faster. The scores are not as good as in Phil's Super Socket 7 system, but they're not too bad either. Okay, that's all for today. As it turns out, these 430TX boards are pretty fast and can be used as an alternative to Super Socket 7 boards, which are increasingly hard to come by these days. There are definitely some drawbacks like the 83 MHz FSB, the 500 MHz maximum CPU frequency, and the lack of an AGP slot. But given that there aren't too many K6 CPUs above 500 MHz and that the AGP implementations of the Super Socket 7 chipsets is buggy, I think that you're not missing out too much. Anyway, I hope you enjoyed watching the process of maxing out this board. Thank you for watching, and I hope to see you in a future video. Bye!